For number 38, ask to the nearest degree, find the measure of the central angle for arc JK if the length of JK is 2.4 units and the radius is 6 units. Okay, so we're talking about a circle here and some central angle, but we don't know what that is yet. So we'll call it M degrees. And it is the central angle that has points JK on the circle. And they tell us that this arc measure, we don't know it in degrees, but we do know it in units of length. So that's 2.4, and that could be inches or feet or miles. But we want to find how many degrees that is, because then it would give us the angle measure of the central angle. There is a formula that we use that says the length of an arc is equal to 2 pi r times the measure of the arc, or the measure of the central angle, over 360 degrees. They tell us that the radius is 6, and they tell us the length. So I can plug in the length and the radius and solve for m, which is my missing piece. So that's 2.4 equals 2 pi times 6 times m over 360. So I'm going to simplify that real quick. 2.4 equals 12 pi times m over 360. Okay, and there's a couple of steps you could do next. Let's just go ahead and divide both sides by 12 pi. That's approximately 0.0637. And then we can multiply both sides by 360. They said to the nearest degree, so that is approximately 23 degrees would be the measure of that angle and that arc. Okay, for number 39, it says find the measure of angle RSP. RSP is right here. So I want to know the measure of this angle. So I'll need to know what X is. And this is a quadrilateral that is inscribed in a circle. So you should remember that in this case, the opposite angles of the quadrilateral are supplementary. So it means angle P and angle R, they add up to 180. So that gives me an equation that I can solve for X, and then I can plug it back into angle RSP. I'm going to simplify this side of the equation to 8x, and I can solve by subtracting -20 on both sides, and then dividing by 8, and find that x equals 20. If x equals 20, then I can go back and plug it in over here. So it's 4 times 20 plus 25, which is equal to 105 degrees. So angle RSP is 105 degrees. For number 40, we're asked to find the area of a rhombus if diagonal 1 is 6x plus 4 centimeters and diagonal 2 is 10x plus 10 centimeters. And in this case, you're not going to actually be solving for a numeric answer. It's going to be a variable answer. It'll have x's in it. We have to remember that the area of a rhombus is diagonal 1 times diagonal 2 divided by 2. So if we substitute the information that they gave us, 6x plus 4 times 10x plus 10 divided by 2. So when we're multiplying two binomials, we have to distribute both terms. So we have to take the 6x and multiply it by the 10x and the 10. So it gives me 60x squared plus 60x. And then we have to take the 4 and multiply by the 10x and the 10. So that's plus 40x plus 40. And that's all over 2. Okay, and simplifying, I get 60x squared plus 100x plus 40 all over 2. So I can divide each of those terms by 2. Gives me 30x squared plus 50x plus 20. Okay, the last one says the area of a trapezoid is 240 meters squared with a base 1 of 15 meters and a height of 8 meters. Find the measure of the second base. Okay, the formula for trapezoid is base 1 plus base 2 times the height divided by 2. So we're given the 240 equals 15 plus base 2 times 8 over 2. First thing I'm going to do is reduce the 8 over 2 to 4 over 1. And I end up with 240 equals 15 plus base 2 times 4. I'm trying to get to base 2, so I'm going to divide both sides by 4. And that gives me 60 equals 15 plus base 2. And now I can subtract by 15 from both sides, and I'm left with 45 meters for the length of base 2. All right, that's it. Good luck on your final.